So hi everyone, this is a demo for our reversal prediction in physiological data, and we'll use the conditional random field to implement this prediction algorithm. We also make improvements to the original CRF algorithm by using streaming data and some online updating rules to save time and make as less compromise in accuracy as possible. So let's get started. The the size of the whole data file is about 67 megabytes, and they have like 590,000 tuples in total. And we'll make the file into several segments comprising of 20,000 tuples each. And we'll use the first 20 to make to work as our bench test, and it's about more than half about the total tuples. And we'll first run it with the default settings, which means there's no updating rules, and it will calculate its model each time when new tuples come in, and you can expect it to be really time consuming. So let's try it. No, sorry. All right. So while it's running, I'll talk briefly of the basic motivations for us to make this improvement to the existing algorithm. So we assume that the physiological data from a user will stay the same for most of the time, but there's potential concept drifts that will happen from time to time, but it will happen rarely. I guess not for like within a day, maybe over a year or a month. So we'll say that a model that fits well for data in the past will likely to be a good model in the future. And that's the motivation for our lazy updating rules, which updates as little as possible. And that is the major part that gives us the extra time. So you can see that the CRF model scored 0.99 on the first 20,000 tuples, and it took about 40 seconds to train the model and to apply the model on the testing tuples as well. And for the second iteration, it'll be about the same. We'll see for like 5 iterations, and we'll call stop because there's no point for us to show you a total 20 iterations, and that's really boring. Okay, so here comes the second iteration. And you can see the precision is about the same. There's a little bit difference to like a 4th digit after the decimal. And as we've shown before, that the training time for CRF models will increase more than for linear time. As the size of the trained data grows, it's more like polynomial time or like exponential time. So the choice of 20,000 tuples for each segment is really a disaster for the training process because it's too time consuming, but it yields a really high accuracy, as you can see from the results that have already come out. If we chose like 5,000 tuples for each segment, the running time will be much faster, but accuracy will be compromised because basically for this task, the label data will likely to be 0, which means for they are not interesting to us, and the data that is labeled as sleeping will be for a very small portion, and if you only have like 5,000 tuples for each segment, it's not unlikely you'll find those examples labeled as sleeping. Okay, I guess this is a good time for us to call out our program and start the second part. And we'll say retrain the model if the accuracy is less than 0.95. So you can see that the accuracy will be still very high. Okay. And for the first iteration, it's pretty much the same. It has to go through the whole process to have the model trained, and oh Jesus. And I'll also talk briefly about why CRF models are superior against the traditional SVM. This is because for our example, the data and its adjacent data are very much related. It is likely that a person is sleeping at this moment. He is likely to be sleeping in the future, and he is also likely to have already slept for a long time in the past. So they are not independent incidences. And the CRF use this fact, and it's like a two-way Markov chain, and it rarely updates when the status is already there. So that's why CRF is superior to SVM. And for our example, you can see that for the second round, it achieved the accuracy less than 95%. So for the third iteration, it will go through the whole process again. Let's just wait. Okay. And after this point, the process really fast, and you can see that the accuracy doesn't change much from as compared with the default settings. And basically, there's no need to train again for like a very long time period. That is where the extra time comes. Okay, here's the final result. So I guess it's a good point to call out the demo. Thank you so much, guys.